Chapter 6, Section 5, Indirect Proof. Now, don't get too scared on this one. It's just proving some things. We may not have to actually use proof tables or anything, just looking at things in an indirect way. I think the book uses a pretty good example. I'll just kind of paraphrase. So every Tuesday, let's imagine it was Taco Tuesday at the middle school. And we know it's Taco Tuesday because the school always serves tacos on Tuesday. And we always come in, and let's just imagine in a perfect world that we would walk in and there would be chips and salsa, and there would be just things you would typically see at a Mexican restaurant when you go out. But you come in this Tuesday and you notice that there's no chips and salsa. There's no, it just doesn't have the right feel. And so you look around and you see ketchup and mustard on the table. And by golly, and yes, that's a word. I'm using the word by golly. There is they've decided to make it Hamburger Tuesday. And although it doesn't roll off the tongue, it doesn't sound good at all. You just, you roll with it and you understand, well, today's not going to be Taco Tuesday. And I know I just talked a lot to get there, but you make an indirect reference. Maybe you wake up in the morning and you've got shorts on and you look outside and the sun is shining. But welcome to Oklahoma. It's now, could be in the wintertime and you walk out, just because the sun's shining doesn't mean that it's 70 degrees, and it might be 7 degrees. And so you would indirectly say, well, I better go back in and not have some shorts on. So again, indirect proof. So let's look at some mathematical examples. Let's say I have a triangle, and that triangle looks like this. And I'm going to call it ABC. And let's say that this side is 18, this side is 12, and this side is 9. Let's use indirect logic, and you tell me, I want you to list the angles, angle A, angle B, and angle C, in order from least to greatest. Which angle is the smallest, which one's in the middle, and which one is the largest. So go ahead and hit pause and make that list. Okay, so since we have the longest side should be opposite the longest angle. The middle side should be opposite the middle angle. And the shortest side should be opposite the shortest angle. So that means, in order, our shortest angle is angle B, or our smallest angle is angle B. Our next angle is angle A. That's our middle one. And then, obviously, that leaves us for our last one. Which color did I do? I did yellow, which would be angle C. So we can infer indirectly that the smallest, the mediumest, I use mediumist, that's a good word, and then the largest angles are opposite the smaller angle, the smaller side, the medium side, and the long side. Get a little tongue-tied here. So again, just using indirect reasoning to state that. So now let's look at one final thing. This is called the triangle inequality, and still in yellow. It would seem that we could take any 3 lengths and we could make a triangle. However, that is not necessarily the case. Let's say you had Oh, well, we'll just get an example here real quick. According to the triangle inequality theorem, the sum of the lengths of any two sides of the triangle has to be greater than the length of the third side. Okay, so sum of two sides has to be greater than, use the greater than sign, than the third side. Okay, so let's look at a common right triangle that we know works. We've got the 3, 4, 5 triangle. And so let's just look at the different sides. We've got 3 plus 4. We've got 4 plus 5. And we've got 3 plus 5. 3 plus 4 would have to be greater than the third length, which is 5. That is true. 7 is greater than 5. 4 plus 5 has to be greater than 3. That's absolutely true. And then 3 plus 5 has to be greater than 4. Okay, so they may give you different side lengths of a triangle. And let's say, I think one of the ones they give is 8, 9, and 18. And so we would do the same thing. We would do 8 plus 9 has to be greater than 18. 9 plus 18 has to be greater than 8. And then 8 plus 18 has to be greater than 9. Well, this one works, but this one does not work. So if I had a board length of 8 and a board length of 9 and a board length of 18, there's no mathematical way to make a triangle out of those lengths. All right, and that is Chapter 6, Section 5, Indirect Proof.